Studying transformations of functions can be overwhelming, but it doesn't have to be. In this video, I'm going to show you 4 things that you need to know to work your way through any transformations of function problems. And the chances are you probably already know 3 of them. So that's only one more thing to learn. So the first thing that we need to know is that adding and subtracting causes a shift in the graph. Right now on the screen, you're seeing what I mean by a shift in the graph. It's when we take our parent function and we either move it left, right, up, or down without changing how it looks. We're just changing its position on the coordinate plane. The second thing that we need to know is that multiplying or dividing by numbers will cause our graph to either shrink or stretch. Let me show you what I mean. In this example, you're watching what happens when I stretch or shrink the quadratic function. What happens is that it either gets skinnier or wider. What's really happening is that the y values, or the outputs of the function, are being multiplied by the constant. The third thing that we need to know is that multiplying by a negative causes the graph to reflect, either over the x or the y axis. For now, it's really just important to know that multiplying by a negative number causes it to reflect, as you're seeing right now on your screen. It's finally time for the 4th thing that we need to know when it comes to transformations of functions. This is the most important one, because this will tie everything together and it'll help you understand why certain things are happening certain ways. This is also really important because you probably already knew the first 3, but this 4th one is what ties it together and gives it more specifics. The 4th thing that we need to know about any transformation of functions is that anything that is happening on the inside is going to be a horizontal change, and anything happening on the outside is going to be a vertical change. Now, what do I mean by inside and outside? So you'll see in our equation right here that we're adding 3 to the whole equation. And what that's doing is it's giving us a vertical shift. And the way that I worded it just a second ago, we're adding on the outside. And since it's on the outside, it's going to be a vertical change. And this one, we're adding by 3 on the inside, meaning wherever the x is and whatever is happening to the x, we add by 3 there. This makes a horizontal change. We can see that our graph moves to the left 3. But wait a second, that doesn't make sense. Why does it move to the left if we're adding 3? There's a little sub point to remember. When we're doing horizontal shifts, we do kind of the opposite of what we would think. So when we add 3, instead of going in a positive direction, we end up going in a negative direction. And if we subtracted 3, we would go in a positive direction. This rule also applies to stretching and shrinking. And this is another one of those little things that we need to remember. For a vertical stretch, our constant that we're multiplying by is greater than 1. And for a vertical shrink, it's less than 1. The opposite is true for a horizontal stretch and shrink. A horizontal stretch happens when the number is less than 1, and a horizontal shrink happens when the number is greater than 1. But the other rule still applies. If we're multiplying on the inside, it's a horizontal change, and if we multiply on the outside, it's a vertical change. The only thing that could make that a little more complicated is if it's negative. So if it's negative 3, that is considered greater than 1 because the negative was not what we're looking at for a stretch or shrink. The negative is what we look at for a reflection. Finally, let's look at that reflection. This one doesn't translate exactly the same, but we can still use it. If we take the exponential function and we multiply the whole thing by a -1, since we're multiplying the whole thing by -1, we can think of that as multiplying by a negative on the outside. And remember, if we're doing things on the outside, we can call that a vertical change. Now what happens is we reflect over the x-axis, and we don't think of the x-axis as a vertical change because we usually think of the x-axis going left and right. And that's still true, but our graph is making a vertical change when it flips from the top down to the bottom. This is how we can still use this rule with reflections and have it technically be right. You just need to make sure in your answer that you say that it's reflecting over the x-axis if they're asking for that. And those are the 4 things that we need to know. But things get a little complicated when there's more than one transformation happening to a function. And it's things like this that make me want to really drive home the point that just watching this video doesn't make you an expert on transformations. You do still need to go mess with some functions and play around with some transformations to really get the hold of it. But for the most part, the 4 things that we talked about in this video are going to help you out a lot if you're stuck or just on a base knowledge level. Once you mess around with some functions and you get a feel for how different functions act, then you'll be an expert. Thanks for watching.